Hey, third hour, group A. This is the continuation of 1-3 notes. So if you remember, we didn't get quite finished with all the examples from lesson 3. So this is the last little bit that you'll need in order to do the 1-3 homework. So, example 2. Rationalize the denominator. So if we're going to rationalize the denominator, that means the denominator is not rational, or in math words, we use the word irrational. Okay? And the reason we do this goes back a long ways because we used to not have calculators. But let's say I have something like this. 2 times the square root of 2 over the square root of 5. So what's in the denominator right now? We have the square root of 5. And the square root of 5 is an irrational number. So we need to rewrite this expression in a way that actually has a rational number as the denominator, not irrational. So the way that we do this is to multiply by 1. And I'm going to put 1 in quotation marks because it's not going to just look like 1, okay? There's lots of ways that 1 can look. So for example, 4 over 4, that's 1. 1.3 over 1.3, that's equal to 1. Pi over pi is equal to 1. X over x is equal to 1. Square root of 5 over square root of 5 is equal to 1. Because anytime you write a fraction where both the top and the bottom are the same, that is equal to 1. So we're going to be strategic about what 1 looks like when we multiply it. And here's what we're going to do. To rationalize the denominator, you multiply by 1 so that the top and the bottom match whatever the denominator is. So in this case, I'm going to multiply by the square root of 5 over the square root of 5. And I chose the square root of 5 because that's what was in the denominator. All right, now what do we get from that? Well, I'm going to multiply across, so I get 2 times the square root of 10, because I do 2 times 5. And then I'm going to do the square root of 5 times the square root of 5, which is the square root of 25. Square root of 25, I can actually take the square root of that, which gives me 2 times the square root of 10 over 5. And that's it, because now my denominator is a rational number. 5 is a rational number, so I'm done. I don't have to do anything else. Let's try another example. Let's say I have the square root of 8 divided by the square root of 18. Okay, to rationalize the denominator, I'm going to multiply by 1. And what's my version of 1 going to be? It's going to be whatever the denominator is. So I'm going to multiply by the square root of 18 over the square root of 18. Now, if I grab my calculator, I'm going to do 8 times 18. So I have the square root of 144 over 18 times 18, the square root of 324. Now, hopefully you recognize 144. That gives me 12. And the square root of 324 is 18. Now that makes sense, right? Because what times itself is 324? Obviously 18, because that's what we just multiplied together to get 324. All right, almost there. Can we reduce 12 over 18? Yes, we can. That will simplify to 2/3. Okay, so that's rationalizing the denominator. All right. Example 3. Adding and subtracting. All right, I want you to think of adding and subtracting just like you would think of combining like terms. So for example, if I had you do 3x plus 5y plus 6x minus 2y, and I asked you to combine like terms, hopefully you would be able to know that you can combine the x's together and that would give you 9x, and you would combine the y's together and that would give you 3y. And we can't add those together because they are not like terms. Well, the same rule applies for radicals. So, part A, let's say I have 3 square roots of 2 plus 5 square roots of 3 plus 6 square roots of 2 minus 2 square roots of 3. So with this rule, I can only combine square roots that have the same number under the square root. So what can I combine with 3 square roots of 2? 6 square roots of 2. 3 square roots of 2 plus 6 square roots of 2 is 9 square roots of 2. Now I have 5 square roots of 3. What goes with that? I have a minus 2 square roots of 3, which gives me a positive 3 square roots of 3. And that's my answer. I cannot combine those together, so I'm done. All right, one last example here. Let's say I have the square root of 12 plus 5 square roots of 3. Okay, I can't combine those together because they have a different number in the square root. However, I can simplify the square root of 12. Is there a perfect square that goes into 12? The answer is yes. What is it? It is 4. 4 times 3 equals 12. So I'm going to rewrite everything. Now, I can actually take the square root of 4, which gives me 2 square roots of 3. So what you have to realize is that the square root of 12 is the same thing as 2 square roots of 3. So if I type in square root of 12, I get 3.46. If I do 2 times the square root of 3, I get 3.46. So they look different, but they are in fact equal. Now, looking at what I have 2 square roots of 3 plus 5 square roots of 3. That's going to give me 7 square roots of 3. Okay, and that's it. Make sure you check Google Classroom. I believe you're going to be doing numbers 18 through 40 evens for this lesson. We'll see you soon.